Good evening to each and every one of you. I hope I am audible.
Yes, sir. You're audible. Namaste.
Namaste, namaste. So, yeah, once again, good evening to each and everyone in the session. Irfan this side from EDL MOU division of XLR. So, we are crossing 200. So, let us wait for a few minutes so that other faculty members will join.
Yes, yes.
Yeah, so I request to all the faculty members, please ask your colleagues, friends to join the session at their earliest convenience so that we can start the session on time. Yeah, so faculty members are joining. The count is increasing. We are reaching to 250 now. So let us wait few more minutes so that other professors and faculties can join the session. I request chat box also so that if any faculty members getting the problem to get into the Zoom, they can refer to that link.
Repeat, please. Actually, I missed your voice.
Amar, you are not audible.
Can you repeat, please? Actually, I missed your voice.
Yeah, so I just request you to post the Zoom link in the chat box so that the faculty members will get easy to get into the Zoom link.
Okay, yeah, sure. Just now, please make sure that you're sharing the link.
Yeah. Yeah, thank you, Amar. Yes, that is helping. And faculties are joining the session quickly. We are crossing 300 now. We are reaching to 300. So once we reach the 500, then we will start the session. I again request to all NIST faculties and staff, please ask your colleagues to join the session at their
Yes,
earliest
sir.
convenience.
Already, yeah, Irfan sir already shared again in the group also. Okay.
Okay.
And the Zoom link, as Abhishek ji perhaps shared, and already shared the link with our faculty members in the groups. Okay, sir. And
Okay.
already
Thank
our
you.
principal sir and the research head already joined in this meeting. So as you mentioned that once we will reach near about the 500 like figure, because people are slow joining, so we may
Yes,
wait
yes.
for a couple of seconds. So after that we may start. Hardly it may reach 3.10 like that, and I am expecting that by 3:10 we will reach our expectation target.
Sure, Dr. Bojo, sir. Thank you. Thank you for the
Yeah,
information.
thank you. Yeah, please.
Let's get started, dear faculties. Without wasting more time, let's dive into the session. Welcome to the National Faculty Development Program on Learning for NLP and Computer Vision in collaboration with NIST, National Institute of Science and Technology, Berhampur, Odisha. First and foremost, I would like to express my deepest gratitude to NIST Berhampur for their unwavering support and partnership in organizing this faculty development program. NIST's commitment to academic excellence and technological advancement has been instrumental in making this national FDP a reality. I welcome from NIST, I welcome Dr. Vishnu Kumar Nayak, sir, Principal in Charge, NIST, Berhampur. Dr. Sandeepan Malik, Head, Research and Innovation, NIST. Dr. Brojo Kishore Mishra, Head, School of Computer Science, NIST. I heartily welcome to all of you dignitaries. From XLR, we have with us today our Associate Director, Mr. Amit Saha. Secondly, Ms. Akanksha Modi, Assistant Manager, Training and Delivery. And Amar Shevte, the LMS Administrator, who will going to walk you through how to use our beautiful LMS. Now I would like to request Dr. Brojo Kishore Mishra, sir, to brief the dignitaries from NIST. Over to you, Dr. Brojo Kishore Mishra, sir.
Yeah, thank you, sir. Namaste. Namaskar to all. This is Dr. Braj Mishra from NIST Barampur, Head of School of Computer Science. Yeah, first of all, we are very much grateful to XLR and especially the Joint Director Amit Sahab and Irfan Sahab and Modi Sahab, Modi and Amar Sahab, because with their support only, we are going to host the second event with in association with XLR and really and very recently our students also get benefited out of 2-3 events and just before I will share our about the NIST. I would like to share one view of one student. She was surprised that when she received when she got an email from the XLR that she qualified and she received the participation certificate because it was around 30 hours of session of full stack web development and because XLR is not only conducting the one-based session, they are hosting the events both way. Even though students can ask the question and their problems can be resolved right there only. So that's why the programs are very much user-friendly. But most of the times, we people are finding that all are the recording mode, but here they are XLR people are organizing in a differently. That's why students and faculty members are also getting benefited out of it. So we are very much thankful to that we are associated with XLR team and they are doing great jobs for the learning development. And regarding this NLP program, as you know very well that AI, although AI concept is the outdated one, but people now by the vast use of data and I mean the internet, AI and innovations concept is AI is the called the buzzword for all of us. So and NLP is one part of the AI. So and computer vision NLP both are highly demanded areas. So even though NLP subject and computer vision subject you will find in BTech syllabus, MSc syllabus, and MTech syllabus. So XLR and NIST is going to host the refresher course for NLP and computer vision so that the faculty I mean, the faculty can brush up their knowledge on NLP and computer vision so that they can deliver the session in a perfectly. With that objective, we have planned to coordinate one refresher program on NLP and computer vision. So, and finally, and XLR also agreed with our view, and we are going to host the event very soon. And regarding the NIST Barampur, although our vice principal, principal in charge, Professor Vishnu Karnaik sir, and our head R&D, research and innovation, Professor Sandeepan sir is there, they will discuss with you all about NIST Barampur. Just I would like to mention over here that NIST is not only meant for the academic, we all are looking for the 360-degree perspective of students' development so that the students will be the one brand ambassador in terms of knowledge, in terms of innovation, in terms of research. Everywhere our students will rise. So with that thought, we are working on it, and that's why some during 2016-17, like 17, we got a very good achievement that I mean in NRF ranking, our rank was around 63. So NIST proved a lot, and it is only possible due to the faculty members and the students' involvement. So with that thought, I'm just requesting right now. I request our principal in charge, Professor Vishnu Naik sir, to say something in this forum. Over to Vishnu sir. Vishnu sir, you are there?
Yeah, thank you very much,
Yeah, please.
Professor Mishra. Good afternoon, one and all. Honorable Mr. Irfan Chowkle, Senior Manager, XLR, Mr. Amit Saha, Associate Director, Mr. Amar Sevaste, Senior Executive, Mr. Akanksha Modi, Mr. Vikas Nurine, the trainer of this particular program, the head of the department, Computer Science, NIST Barampur, R&D head, Dr. Sandipan Malik, my faculty members, esteemed guests, and distinguished participants. A good afternoon, one and all. Once again, it is with great pleasure and enthusiasm that I'm here at the National Faculty Development Program on learning for natural language processing, NLP, and computer vision, with a special focus on its application in the business analytics. This initiative, generously provides by XLR, embodies the spirit of collaborative learning and advancement that NIST College is deeply committed to. The Memorandum of Understanding signed with XLR is a testament to the shared vision of both institutions working hand in hand to push the boundaries of knowledge in these cutting-edge fields. In today's dynamic world, the intersection of NLP and computer vision with business application is not just a niche interest but a critical frontier that promises transformative outcomes. These technologies are reshaping how business operate, make decisions, and connect with their customers. They hold the potential to unlock unprecedented efficiencies and insights, driving innovation and competitiveness. As educator, it is our duty to stay at the forefront of this advancement, equipping ourselves with the tools and knowledge needed to prepare the next generation of leaders and innovators. This program, toiled by XLR, promises a deep dive into the intricacies of NLP and computer vision, offering a unique opportunity for our esteemed faculties, participants to gain hands-on experience and expertise in these fields. I encourage each and every one of you to approach this program with a spirit of curiosity, determination, and a commitment to lifelong learning. Embrace the challenges, ask questions, and collaborate with your peers. The knowledge and skills you acquire here will not only enhance your own professional development, but will have a ripple effect, positively impacting the quality of education we provide at our institutions NIST. Let us seize this opportunity to further elevate our institutions standing as a hub of innovation and excellence in education. Together, we will not only explore the depth of NLP and computer vision, but also find innovative ways to apply these technologies to the world of business. Once again, I extend my heartfelt gratitude to XLR for their invaluable partnership and support in making this program a reality. I have no doubt that the knowledge gained here will not only benefit our institution, but will also contribute to the broader landscape of education and industry. Thank you. I wish each of you a rewarding and enlightening journey throughout this program. Thank you very much.
Yeah, thank you, sir, for your encouragement words and really inspired, sir. Now, I would like to request our head research and innovation, Professor Sandipan Malik, sir. Sandipan, sir, you are there? Hello. Sandipan, sir. Yeah, maybe he lost the connection.
Dr. Bojo, sir, I think he is not in the room.
Yeah, he may be. Okay. So before we will start this program in a proper, and before I will hand over to Irfan Sir, once again I would like to give the best wishes to each and every participants, because it will be one-to-one program and you can directly interact with the mentors, and we are very much thankful to the mentors who are going to handle the sessions. So on behalf of NIST Barampur, once again I would like to give a big thanks to XLR team and the mentors who are going to uh, handle the session, and a big thanks to the participants who are ready to learn a lot from this session. Over to you, Irfan sir, please.
Yeah, thank you, Dr. Bojo sir. Thank you for your kind words. And also thank you for the principal sir, honorable principal sir, for their valuable guidance. Now, I would like to request our associate director, Mr. Amit Saha, who will walk through us about the XLR journey, the everyday learning programs, and MOU collaborations. And also, he will be going to introduce our subject matter expert today. Yes, Mr. Amit Saha, sir, please.
Very good afternoon to all of you. Thank you, Irfan, for introducing me. And once more, a very warm welcome to all the dignified guests. First of all, starting off with, I would like to acknowledge the participation and the cooperation showed by the management of National Institute of Science and Technology, one of the premium most higher education institution in the state of Odisha, and also have a prominently placed in the higher education institution mapping nationally. So I would like to acknowledge the presence of Dr. Vishnu Kumar Naik, Principal in Charge of NIST, and the wholehearted support from Dr. Sandeepan Malik, Head of Research and Innovation, and as well as Dr. Brojo Kishore Mishra, whose constant support and as well as constant follow-ups and the interest has actually triggered us to conduct this particular workshop in association with NIST. So before I move on, I would also like to thank my own team out here with the team of training and delivery management of Akanksha Amar, and definitely the person behind the entire show, that is Mr. Irfan. So let me just share my screen. So yeah, Irfan, if you can kindly confirm whether my presentation is visible out here.
Yes, Amit, it is visible.
Thank you so much, Irfan. So XLR Solutions, we stand for the primary motto that education is not only a preparation for life, but that's education is life in itself. With this motto, we brought together this everyday learning program. The concept is very simple. That is, any individual in the pursuing higher academics or any individual who is a part and parcel of the higher academics want to acquire knowledge and expertise on a particular technology, on a particular tool, if a constant learning, a disciplined learning of 2 hours a day can definitely create the pathway for acquiring the knowledge. So that's how the everyday learning program initiated, and then gradually we curated this program, and today we stand boldly speaking out that we are having this association with close to around 980 higher education institutions across the country. Very soon we will be breaking the threshold of 1,000. And then definitely there is no looking back. We are going to go ahead with on an aggressive note, having more and more higher education institutions becoming a part of this particular program. This program is dedicated to the students, to the faculty, and the higher education institutions across the globe who want to accelerate and enhance embrace the dynamics of cutting edge technologies that Principal Sir and Dr. Mishra was speaking about a few minutes back. And that can be easily accessible, readily accessible from any individual across the globe at any given point of time. Yeah, I definitely once more highlight on the factor that at any given point of time, that knowledge platform should be accessible. How? We will definitely discuss further in the next few minutes. The areas in which we expertise, or the areas in which we focus upon, starts from data science, machine learning, deep learning, data and business analytics, cloud computing, artificial intelligence, digital marketing, software testing, DevOps, full stack, web development, SQL, and many more. We started off with a humble beginning in 2014 from a headquarters based out of Houston, USA, and it's 10 years, which was started off by some of the IM and ISB alumni. We have been able to make the humble journey of impacting the life or the career of close to around 3.5 lakh students and professionals by training them in the technologies that I just mentioned. So we have been growing by leaps and bounds. Definitely, this has been possible primarily because of the never-ending support from the academia. And that is the reason why we have been able to also get some of the prominent giant industry partners associated with us in multiple formats, whether it is for their own in-house manpower upskilling programs or their recruitment for forecasting and getting satisfied through their recruitment requirements, or else working collaboratively through designing different programs as per the need of the industry. Academia has never been left behind. So some of the prominent names in academics also has been constantly supporting us across the entire geography, whether it is nationally or internationally. During shortage of space, we have just highlighted a few of them. We have collaborations with more than 100 plus top higher education institutions and bodies across the globe today associated with XE, and more than 400 plus prominent leading industries which are associated with XLR in different format. Everyday learning for free. This was what was the concept. So affordability is something which definitely are limited to a certain strata of the society, as we understand. But then learning can never be a barrier for such. Keeping this transparency and thought in our mind, we started off with this everyday learning about 12 months back. So the idea, when we ideated this whole thing, the concept was primarily to get into association through industry MOUs with the different higher education institutions, starting off with conducting industry webinars. But then gradually it got enhanced and broadened. And we got a shape today which we can closely consider as a 360-degree of preparation. So it starts from conducting student development programs for the students, faculty development programs for the faculty, webinars and seminars provided by the industry experts, lifelong learning for the participating learners, whether it's student or a faculty, through the LMS platform, the learning management system platform that we provide in the live and as well as in the self-paced version, the professional trainings provided by the industry experts, handpicked from the industry, the assignments provided as a part of the package, and assessments of those assignments provided as per the specific request from the respective institutions. Moving on to support on the projects and internships, where a collaborative, chain of action can be designed in association with the AGI who are requesting for such support. And finally, on multiple modules provided under the placement preparation support, including resume builders, LinkedIn profiling, mock interviews, soft skills development, so on and so forth. It is something which is it is absolutely dynamic. So this is the shape which today we are having, but on an everyday basis, we are going on enhancing the entire module in a constant move. So the motto or the objective is very, very clear. Provide application-oriented training for students and faculty. Hands-on training on the training technologies so that they get the practical understanding through the real life case studies, because real time is something which is uh, you know becomes mostly impractical in most of the cases. And then documenting each and every step of the way and providing the documented formats as per the request of the institutions in a proper format, so that the institutions or HEIs can utilize it for their NAC NBA accreditation requirements. So these are, as Mr. Irfan has already mentioned, these all deliverables which falls under the non-commercial benefit that is passed on to the institutions and naturally to the students and faculty of those institutions. So thereby providing the SDPs, FDPs, and webinars and seminars. Again, I repeat, the lifelong learning provided through the LMS and supported activities through projects, internships, and placement preparation. This closes the entire loop in a formidable way so that those who can make maximum utilization of this support can definitely improve their skill set and make them more industry ready as far as the students is concerned, as far as the faculty is concerned. They can take inputs from this particular model and can curate modular programs to be delivered at their respective institutions for their students. So in a nutshell, we provide free quality training, instant lifetime access for the LMS, experienced faculty handpicked from the industry, as we have with us one very dignified faculty or trainer from the industry today for taking up this uh, fantastic program on natural language processing and computer vision. Hands-on learning provided through the real-life case studies, providing the students with the vision on the high-demand careers on the same domain, boost their profile to make their profiles more marketable through some of the tools like LinkedIn profiling, resume builders, so on and so forth. Gain expertise in the emerging technology or the cutting edge technology area. Motivate them through the providing them certification of participation, and finally the internship certificates if that is concluding through a project and internship. LMS will be taken off in more detail by Mr. Amar during the course of our discussion. And there is the kind of a training calendar that we maintain. So what I wanted to highlight through this particular slide is that it is not only when we are, of course, it is very important that for the next 5 days, we will have a very engaging journey of learning in association with the trainer from the industry on the natural language processing and computer vision. But anybody who joins in newly as a part of this program can access the other programs mentioned in this particular slide. So which means all the past programs, they can get an access to the swim, not only the recording of the programs, but as well as the tools or the content that was used for during those programs. And for all the future programs, they would be easily able to attend to those programs by logging in to the links that would be provided to them through the LMS. This is a slide more on the projects and internships. I would not spend much time on this on today's date. We have been constantly conducting many of webinars and seminars also from across the country for request of institutions from the higher education segment. Finally, I have already spoken about the NAC and NBA criteria. Many of the faculty who are joining in for the first time today, just for an information, our windows are still open for the association of signing up the MOUs with us for the non-commercial association. So for the free collaboration, program collaboration, you can please kindly reach out to Mr. Irfan and me, and our coordinates are already provided. We will again paste this across in the chat box as well. Please do reach out to us for any kind of an academic association that you would be looking forward. There is a platform which has been created for you. Make the maximum usage of the same. And I am pretty sure we would be looking forward for this association for a long time. Saying so, for any curated programs that are required from your institution side, please do again reach out to us so that our respective team on the academic association side can take it up and would like to work closely with you, trying to understand the needs, and would definitely curate programs as per your requirement. Before I complete my session and hand over to Mr. Amar, I would like to welcome Mr. Vikas Naruni, the subject matter expert with more than 10 years of experience as a data scientist. He is, in true sense, somebody who comes in with a large amount of experience from the corporate, where actually the technologies are getting used on a day-to-day basis. He is having expertise in Google Cloud, big data, and machine learning. He has trained more than 2,000 candidates globally on various data science curriculum. And currently, he is engaged as a data science trainer with a major MNC. On that note, I would like to again congratulate everybody for making out their time and for attending this program, and looking forward for a highly engaging coming 5 days with all of you. On that note, thank you so much. Amar, if you can kindly take over and can just give them a quick glimpse about how they will get the access of the LMS, and as well as how they can get the LMS logins.
Yeah,
Thank you so
sure.
much.
Thank you so much, Mr. Amit, for such a wonderful introduction of XLR solutions and trainer as well. So, my dear participants and my dear professors, good afternoon to each and everyone, and warm welcome to National Faculty Development Program. So, without wasting too much time, I'm directly starting with the LMS KT. So, before starting with the KT, everybody should know that what is LMS. Okay. So, professors, LMS is a learning management system, and it's XLR online learning portal. And if you're using that, we know the use of that particular portal, right? So, to joining the session every day, to get the recording for lifetime, to give the attendance, and to access the material which is sharing by the trainer, you have to go through the LMS. Okay. So to get the LMS access, registration link is mandatory. So I hope all of participants are done with their registration. If not, Chandana, please share the registration link in the chat box of Zoom and YouTube as well. Then they will do the registration process. Okay. So after registration, so you receive 2 emails. First email is a verification email. Okay. So in the subject of that verification email, you are able to see verification email, welcome to XLR, verify your account. Okay, so we mentioned one link, and it's onlinelearning.xlr.com. You have to click on that link to set a password. Okay, if you are able to see my cursor, then here the link is there. After clicking on that link, it will take you through this page. Here you have to mention your password, like whatever password you want, you can keep here. Just confirm that password and set your password. Okay. So as I mentioned, you received 2 emails. The second email is course invitation email for that particular program. Okay. So here the subject is like, welcome to the National Faculty Development Program on learning for NLP and computer vision. So this is the classroom access. For particular classroom, you will get the particular data set. Okay. So we again mentioned the link be like onlinelearning.xlr.com sign in. So this is our URL for learning management system. You have to click on this URL. It will take you to the next page. It's sign in page. Okay. So going forward, if you're not able to find out this mail, then definitely you can go through any of the web browsers. Simply type it down, onlinelearning.xlr.com. You are able to get this page. Simply click on sign in. It will take you to the login page. Here in the login to the XLR page, in email address, you have to mention the email which you use at the time of registration. Okay. And as I mentioned, you have to set the password in first email. You have to mention your password and click on login. That's the simplest way to log in. Okay. Now I will show you directly the way how LMS is to run. Let me reshare my screen and let me confirm once it's visible to you. So my screen is visible. You are able to see the home page.
Yes, yes. Please
Okay.
proceed.
Yeah, sure. Thank you. So first of all, I will show you the ways to join the session using Zoom and YouTube. So participants, I'm on home tab. So here, first way, if you check at right hand side of your screen, you are able to see today's session. In today's session tab, National Faculty Development Program on Learning for NLP and Computer Vision Day 1. And here we mention the date and day and the time. So now you are able to see the join button. Every day at 2:55 p.m. you are able to see the join button here. If you click on the join button, it will directly take you through the Zoom. This is the simplest way to join via Zoom. If you're facing any difficulty to join the session using Zoom, we have alternate option to join via YouTube. Okay. So at upper side of the today's session tab, you are able to see one banner. Okay. So it's YouTube link. If you click on this banner, so it will take you through the YouTube live. And whatever the queries and question, you can post in the chat box. Okay. So our trainer will check on the same. Okay. So next thing, I will explain you how to access the recording, how to view the attendance. Okay. So at left hand side, we are able to see the multiple classroom. I have access of multiple classroom. Don't worry about the other classrooms. We'll search for the particular classroom of National Faculty Development Program. Okay. So let's scroll down and see here, National Faculty Development Program. Okay. So anywhere on this classroom, you can click and you are able to see the start learning, resume your learning. So here there are two tabs. One is curriculum and another one is meet. So first way, I will show you how to give the feedback or attendance. I hope you are able to see the feedback and response tab. And here, please submit your attendance and feedback response here. Okay, so click there and we mention one Google form. So day 1 attendance and feedback form for this particular program. And we clearly mention one notification. The attendance link will only open between 4:30 to 5:30. Okay, so if 4:30, if you came back here and if you see, you are able to see one Google form, you have to fill the details on daily basis. Why? Because we are going to know that how the training program is going on, and 60% attendance is mandatory to get the participation certificates. So every day I'm requesting you, please don't forget to fill the attendance form. Okay. So next thing is that coming to the recordings. So below the feedback tab, there is a session recording. Here, as today we are going to the day 1. If you click on day 1, you are able to see the day 1 recording. Here is a play button. Training program is going on and is going on. Certificates to see. So every day at the after of the session at 5:30 p.m. if you see that, you will get the recording, and that recording will be with you for lifetime. Same, be like here is day 1. Before day 1, below that day 2 up to the day 5, all the recordings will be there. And whatever the material which is going to use by trainer will upload all the materials here. So this is the simplest way to log into the LMS to use the LMS. I hope it's clear. If you have any query or question, please drop in the chat box. I will take it up. If not, going forward, if you're facing any difficulty, drop an email to edl@xlr.com. My team will check on the same and they will get back to you. Okay. So Chandana, please drop an email or Zoom and YouTube as well. If there is no any query or questions, so Vikas, goes to you. Please start with the question.
Okay. So thank you, Amar. First of all, I would like to thank Honorable Principal Sir and the Institute faculty members, and special thanks to Amit Shah Sir and Akansha Ma'am, Irfan Sir, and Amar. Thank you very much. for making my job easy. I know now, guys, everyone know where to check and what to check and how to get started with this program. So, guys, this is me, Vikas Narune. I have having more than 14 years of experience in the corporates, and my entire brief history has been given by the sir. So, still, I would like to give you a one-liner introduction. So, I have been working in this field, especially into the corporate trainings and freelancing from last 2.5 years. And prior to that, I had an experience of 14 plus years where I worked with the major corporates and the MNCs, which were mostly into the Europe and America. I have also, my last assignment was with Asia company, which was headquartered into the Taiwan, and they had their own live streaming application. And wherever I was responsible for the entire project management for the data science and machine learning and computer vision initiatives. So this is how my entire profile or resume looks like. And I hope you guys will enjoy this session going forward for next 5 days. So let's get started without wasting time. And hello to everyone and good evening. And let's get this session very exciting. I hope everyone will like this session, especially into the NLP domain and especially into the computer vision domain, because I'm not only going to give you an introduction or a theory part. So what we can do is I will walk you through an entire corporate project, how to implement whatever things we're gonna learn today about the computer vision going forward towards the NLP. So what I am planning to do is I am planning to take one project for each. Maybe let's have a latest model in the computer vision. So I guess everyone is very well aware of the YOLO NAS model, so which is also agenda for today. So let me share my screen first of all. So let me share my screen and Amar and the colleagues, can you please confirm that I am audible enough for everyone?
Yes, you're audible. You're loud and clear. Your screen is also visible.
Okay, Amar, thank you very much. So guys, let me quickly share the agenda with you guys for the entire 5 weeks. This is how the agenda gonna be. We're going to start initially, guys. We're going to start initially with the computer vision. What is computer vision? What are techniques are there in computer vision? How it's gonna be implementing this computer vision? Why it is important? And once we have to understand the computer vision, guys, there is no other way I can restrain myself from talking about the convolution neural networks. So convolution neural network is going to be the basics. Okay, convolution neural network going to be the basics for understanding the computer vision. So we're going to first understand what is convolution neural network, how the convolution neural network architecture looks like, what are the filters, what are strides, what is pulling. Entire architecture we're going to go into the depth to understand the entire operation, what's going on behind, how this convolution neural network works, what are the different category of this convolution neural network, how they are going to come up with the entire architecture. And once we understand, once we have a good understanding about this convolution neural network, obviously we'll try to look at one project, which will be an image classification project. We'll try to classify the image. Okay, this is a simple binary class classification, two class classification project we create. And what the specialty case for this project will be, we're not going to use anyone else architecture. We're going to create our own architecture. Our own architecture we're going to create. And by creating our own architecture, we can call it as our NIST architecture, our EDL architecture, whatever architecture we want to call it, we are free, because we can also showcase to the world that we can also come up with a kind of a small architecture and which is working, which is workable, which can give us a prediction. So that's a small project we're going to start with. And once, guys, we are feeling comfortable that we can go forward, the major topic and the major attraction for the session going to be a object detection model, YOLO. So YOLO NAS, actually YOLO NAS is the latest model which is released in 2023 only, and which has been released with the DESI company. There's one of the organization. We'll talk about it initially when we'll go into these topics. But this YOLO NAS model, it is specially called as YOLO NAS because it's a neural network architecture based model. So it searches for the neural network architecture, and then it's try to establish the entire architecture. And then we can retrain that. We can train obviously, and then we can have a prediction around it. So it's going to be very, very special model out here. So we're going to understand how the entire YOLO things works. This YOLO is very special. I know I will tell you what is YOLO. YOLO stands for you only look once. What is the specialty? Why they call this as a YOLO? What is the architecture? What is the entire working in that? We're going to understand each and everything from the beginning to the end. And then once we understand what is YOLO, obviously, let me clarify these things. So we can customize that. We're going to customize that YOLO model. First, we'll try to test that model as it is. It is also called as a pre-trained model, because it's a pre-trained model, and we're going to understand that entire pre-trained model's functionalities first. And then we're going to customize that for our own interaction, for our own classes, or for our own use cases, whatever you want. So let's take one category, fault detection. I will explain you in detail when you go into that. And then that's how it's going to be for the computer vision part. I hope everyone is now comfortable and everyone having a greatest understanding of what we're going to cover in the computer vision. Having said that, the second parts, like this is not the single session, like it will take couple of days, at least 1 or 2 sessions will require to complete this computer vision. And then we can start focusing on the core topics of the NLP, natural language processing, where we'll first try to understand, let me clarify the things. We'll first try to understand that what is NLP actually? What is NLP? Why NLP is important? What are the basics of the NLP? If we talk about the NLP, or if we going to talk about the application which are like Chat GPT kind of application, which are the talk of the town nowadays. Everyone wanted to build this kind of architecture. Every company, every organization going crazy. They want Chat GPT kind of application to be built upon. So that's how this how it's gonna look like. So if you want to reach to this Chat GPT, if you want to become the expert, if you want to be a esteemed professional in the field of the NLP, so you have to start with the basics, right? You have to start with understanding that what is NLP, what is the text analytics, what are the basic concepts, how the entire text is going to get converted, going to be cleaned, and then it is going to get converted to the vector. And once we convert to the vector, which is a famous concept out here, which is called as word to vector concept, then only we can apply any kind of algorithm. Then only we can apply any kind of algorithm, machine learning algorithm, AI algorithm, or a deep learning algorithm, and then we can get our entire predictions. So this, once we understand the basics, then we have to understand, once we understand the basic, then we have to move toward the very important step, that is understanding the recurrent neural network, because recurrent neural networks are the base for the Chat GPT kind of application. And we'll understand why recurrent neural networks are important, what are their applications, what is back propagation, forward propagation, even in the neural networks, this recurrent neural network. Then we try to understand very famous architecture, which is LSTM and GRU models. These are the very famous long short-term memory models. And if the time permits, guys, if the time permits, we can also talk about the transformers. Obviously, the transformers. I don't want to burden you guys with a lot of knowledge, but we should be able to make most out of it. So we'll try to understand at least, or we'll try to have a look, like in the last day, I will try to dedicate a couple of hours to understanding the generative AI. What is generative AI? What is prompt engineering? What is large language model? And this large language model, which are constituting towards the Chat GPT kind of a model. Chat GPT kind of a model. Okay. So we'll try to understand one simple model, which is the family of the Chat GPT, a GPT-2 or 1 model, GPT-2 or 1 model. Very small code walkthrough. We'll try to make it, and that's how it's gonna conclude the entire series of this computer vision and NLP, guys. So I hope now everyone understood what's gonna be there in our plate for next upcoming 5 days, and that's how we're gonna proceed, guys. So all right, I think everyone is now very well aware what is going to be there for you guys and what we're going to cover. So having said that, guys, let's get started. Let's get started for first thing first. So today's agenda, what we're going to do is, today we're going to start with very basic steps regarding this one. What is computer vision? What are the techniques available? What are application? And we'll try to start with the convolution neural network. And then we'll obviously we'll go into the detailed deep dive into the convolution neural network, and this how it's gonna look like. All right, guys. So everyone can it's a beautiful crowd out here. It's a good evening. It's a nice and shiny evening out here. So can you guys just give me kind of a confirmation, kind of a thumbs up, kind of a message that everyone is very good to go and we can actually start our session. So if you guys can give me a kind of a thumbs up or kind of a confirmation out there in the chat box, so it will be very amazing for me, guys. Thank you very much, Deepika ma'am. So guys, couple of members, if you can give me a go ahead. Everyone comfortable with the agenda? No doubts about the agenda, then we can start the session now, actual session. Thank you, sir. Singh, sir, thank you. All right, guys. So since I've got a go ahead, so without wasting the time, let's go ahead then and try to understand the next session. Okay. Ayush, thank you. Let's go ahead then. So guys, first thing, like what do you mean by computer vision? Why actually we require computer vision and what are the use cases of the computer vision? So what is the computer vision? Okay, that's the first thing that comes to my mind. And why should we focus? Why should thank you, Vijay Kumar sir. Jeshna, thank you, ma'am. So everyone, thank you very much. Om Patil, thank you. So guys, thank you very much for your support and kind of appreciation for giving a go ahead. So let's try to understand, guys. Let's try to understand that why we have this computer vision topic out here and what is the specialty, like where it stands and what are the intricacies of this computer vision. So I think this slide is somewhat clustered. So let me go to the next slide if I have a space. And then, okay, this side is better. So first, let me tell you guys that where the computer vision lies and what it is a part of what. Okay, that's what we'll try to understand first. So let me go ahead first. Let me go ahead and let me draw one picture, which is very, very popular picture, which is very important picture that we should be able to understand. Okay, thank you, ma'am. Manjula, ma'am, thank you very much for confirmation. So guys, let's try to understand first when we talk about the computer vision, CV, I'm going to call it a CV. So where it stands actually, what it is a part of the AI, whether it is a part of the machine learning, it is a part of the deep learning, or whether it is going to be a cross section of everything. That's what first thing comes to my mind when I talk about the computer vision. So let's imagine AI. This entire box is AI. This AI is the entire world. We can consider this entire world or entire population as AI. Okay. So in AI, guys, in AI, we have something called as machine learning. ML. So AI, when I talk about AI, we can simply say AI, we are making machines, right? We are making machines. We are making machine intelligent, right? I am writing I for intelligent. Shortcut, guys, please try to understand. I am saying that when I talk about the AI, AI going to be make these machines or robots or software are intelligent, just like the human beings, That is my AI. AI could be software. AI could be software. AI could be hardware. So what could be the examples? What could be the example? Can anyone like tell me what could be the example of AI as a software and AI as a hardware? You guys can post me in the chat box. So what is your understanding like AI as a software and AI as a hardware? Can you guys like quickly give me a kind of a understanding what you guys are having or any kind of a application name which you can suggest like which is a hardware we are using and which is a software? Yeah, great, Vinayaka sir, great. Software as a chat GPT, correct? And then can anyone give me hardware? Cars. Yeah, cars. Yeah, machine, correct. Cars. Hardware as robot, correct. Awesome, guys. So let's take an example. All right. Thank you very much, guys, for your response. Let's take an example. AI as a software. AI as a software. Everyone having a mobile phone. Everyone has a mobile phone. And in the mobile phone, guys, I am sure everyone has this face detector app, and with this face detector app only, you guys are able to unlock your entire mobile phone, right? Remove the background color, generate the picture. Yes, correct, guys, correct. Awesome. I think you guys are already deep into the topics. So Vijay Kumar, thank you. So okay, Prasad sir, thank you. Thanks for your answer. Okay, problem solving, yeah, Vaishnav, correct. So guys, try to understand that everyone having, yes, this face detector, sir. Thank you for the confirmation. And you guys are machine orientation, correct, guys? So everyone is able to unlock their cell phones with using this kind of a face detector. This face detector will be able to take your picture, obviously, and through the camera, through this picture, guys, and it is able to unlock your phone once it is matches the pattern. So we can simply say this kind of a things as a software. And the hardware, like you guys already told me, kind of a machines, hardwares or robots. So we can say robots, we can say the drones, right? Or we can say any kind of amazing stuff like Alexa hardware, kind of a smart watches, kind of a smartphones. Okay, so which are using AI in the background. That is what we call this AI or AI as a software, AI as a hardware. So everyone is very well aware, no need to tell these things. Guys, then we have something called as machine learning. Machine learning. In machine learning, guys, what we do is actually we are applying some kind of algorithms, which are mostly the statistical algorithm kind of algorithm. And we apply this on the structured data. The data going to be mostly into the structured format, which can fit into the rows and columns, which I can configure as of now as a rows and columns data, kind of a tabular format data, where I am going to apply my statistical algorithm. This data going to be very huge data is possible. Million and billions of rows could be there. And we are applying our algorithm, this statistical algorithm, something called as y equal to mx plus c. So this sort of algorithm we are applying, y equal to mx plus c. And we are getting our predictions, y hat. We are getting our prediction. This prediction could be a classification, could be a regression, could be a clustering, any kind of a job you are trying to perform. Let it be a regression job, let it be a classification job, or let it be a clustering job you are trying to perform. Okay, this is what we have an understanding about the machine learning, entire machine learning. Let me rub this thing now. Let me rub this and let us go back to our discussion, like what is the computer vision and where it lies. So I said this entire AI is the entire population, entire universe, and there is something called as machine learning inside it. So we spoke about what is machine learning. Now guys, inside machine learning, there is a one subtopic is there. That subtopic is called as deep learning. Subtopic is called as deep learning. And what is this deep learning? What is this deep learning? Try to understand. Here is the DL, here is the ML. Okay, inside this deep learning, what we are using is, we are using artificial neural networks. Sorry for this handwriting. Artificial neural networks. Okay, artificial neural networks, which are famously called as ANN. And what are ANNs? If you could remember, ANNs are copy. They are copy of human brains neural networks. Human brains neural networks. Okay, neural networks. So let me rub this thing now, so everyone understood this one. So this artificial neural network, guys, whatever artificial neural network we are going to use out here, right? So this is artificial neural network, which it uses in the background, like the machine learning algorithm, it uses the statistical algorithm. This deep learning, it uses the artificial neural networks. I am sure you guys have seen this kind of a circle diagram, and which is very, very popular out there when we talk about the artificial neural network, right? We talk about the artificial neural network, and something called as the input layer, something called as hidden layer, and something called as output layer, where we get our predictions, where we get our y hat. And this is what the understanding is the artificial neural network is all about. This is what we already understand, right? Now try to understand, guys. Now try to understand what I've told you here in these three last couple of minutes is that if you want to bifurcate between the machine learning, if you let me use the different color now. If you want to bifurcate between the machine learning, if you want to bifurcate between the deep learning, okay. So this is a kind of algorithm which uses, like this uses the statistical algorithm, and data is tabular data. But in artificial neural network, we mainly focus on the unstructured data, guys. So can you guys, anyone would like to tell me, like what could be the unstructured data? What I am talking about when I talk about the unstructured data, what could be the unstructured data? What could be the parts? Awesome, sir. Abhaya Kumar, sir, thank you. Image. So music, text, video. Yeah, correct. Correct, sir. Barek, sir, yes, correct. Comments, Krishna, correct. Correct, guys. Awesome. You guys are already have a deep into this topic knowledge. So not labeled, correct, Prasad. Yes. So when I talk about videos, when I talk about the image data set, when I talk about the text data set, okay. So when I talk about the audio data set, so all this gonna be a unstructured data which one cannot be in a text format, not a text. Okay, correct, sir. Correct, Vijay Kumar, sir. So your understanding is very, very correct, guys. So what we can simply say is the data which cannot be fitted into the normal tabular format, like video, image, text data, and the audio data, which is unstructured data. And this artificial neural networks, they focus mainly on the unstructured data. And then this unstructured data require the processing, which is not that simple. Okay. So it requires a special kind of architecture. That's why they use ANN, artificial neural network. Now coming back to my question, why we are discussing this stuff? Like why you are wasting time? You can say simply, sir, why you are wasting my time? Why telling me this being? entire Ramayana Katha. What is this entire Mahabharata Katha you are telling? Let's come back to our topic of computer vision, guys. Let's come back to topic of computer vision. Now coming to the computer vision. Computer vision, guys. Computer vision is a part of the deep learning. Is a part of the deep learning. So when we speak about the computer vision, it is a deep learning technique which uses the artificial neural network, which specially works on the image data and video data So it won't be working on the text data. So try to understand when we comes to the text data. When we talk about the sequential data format, we'll speak about the recurrent neural networks. So this computer vision technique, when we talk about, this special uses something called as convolution neural network. Which are the addition to the artificial neural network. And then we have something called as additional layers, which are convolution neural network, and they work on this image and video data, and this is why it is called as computer vision. Why vision? Because it works as the eye of a computer. You can say eye and ear of a computer or a machine or a robot, whatever you want to call it as a machine. So it is the eye and ear of a machine. Okay, so that is called as computer vision. I hope now everyone is very, very clear what is computer vision. So let's go back to our introduction. So what is computer vision? Now everyone understood computer vision in simple terms. If I want to speak about the computer vision, so computer vision, guys, simply called as eye of a computer. This entire eye we are talking about, eye of a computer, and this eye of a computer, or you can see ear of a computer, which specialized in the image and the video data. Okay, so this is what my basic understanding. Now I made a second claim also. In thus this uses convolution neural network, CNN, convolution neural network. And this convolution neural network, guys, we'll try to understand in detail what is convolution neural network. It is a advanced form. Okay, you can say it is a advanced form of a artificial neural network. Okay, so it is an advanced form of a artificial neural network, which in turn create a special architecture which is responsible to extract from the images, from the videos, the special features, which these features goes into the artificial neural network, and then we get in turn our predictions. So now I think everyone got the intuition that what is computer vision. So computer vision talks about the eye and the ear of a computer, which is able to identify the image, which is able to classify the image, which is able to deal with the video data. So this is something which is based on the convolution neural network. This is what I understood now. And there are many applications nowadays. And computer vision is one of the favorite topic for the industry, because most of the advanced tasks, let's take the example in the field of the biomedical field example. So where we are talking about this kind of lady's picture, okay? When this color picture is passed, we have a computer vision technique. Which will be able to convert this entire picture. Into something called as thermal image. And not only it will be able to convert that entire normal image into the thermal image, it will be able to perform identification. You can see some out here, some kind of a red spots are available on the picture. So it will be able to detect this kind of a red spots, okay? And without using the thermal camera, IV camera, infrared camera, IR or IV camera, or without using that camera, guys, you can take the picture, normal picture, you can convert to the thermal imaging, and you can perform a further analysis. What is the issue, what is going on, what is lying in the background, what kind of spots are there, or you can further go ahead and analyze the spots, and you can decide or go ahead and understand whether it is associated to any kind of a symptoms of the disease, okay? So that kind of advanced things is performed by the computer vision. Or let it be a field, like we take example out here, which is a kind of a drone out here. You can see this one drone is there. This is a kind of a advanced drone, a kind of a robot, you can call it as. This robot is deployed in the agriculture sector, guys. Let's take example, very nice example, what it has done nowadays. So this agriculture sector drone, what it's going to do is, it is going into the farm. Obviously, this is a farm you can see out here. In the farm, guys, what we can do is we can train our robot. We can train this robot on the computer vision technology, on the CV technology, which will help us. Okay, once it is trained, let's understand the objective, that it will help us to pick. It will help us to pick a ripened fruit. Okay, ripened fruit. Let's take an example that you have a mango farm. And obviously nowadays in agriculture sector there's a lot of chaos going on due to the heavy kind of a raining, or sometimes very drought, and there is always a shortage for the agriculture sector workers. You're not getting the workers, and if you get workers, you will not be able to afford them. So for small, let's take a very good example. For small farmers or kind of people who are out there, who are our feeders, who are society feeders. For them, what they have decided is that can they apply this computer vision techniques, where they can apply this computer vision technique to a robot or to a drone, which can be fully trained, on the kind of a topic, which can go to a tree. Let's imagine this is a tree, which can go to the tree. Okay, and since it is a computer vision technique, it is based on the image processing. It has been processed with the, let's say, 1 billion. Okay, 1 billion pictures of the ripened mangoes. Okay, and once I am able to pass this training to this robot is going to the trees. Okay, let's imagine these are some raw mangoes. Some are raw mangoes, some are ripened mangoes, some are cherries, some are like mangoes. Okay, mangoes. So what is the job of this model is, based on this 1 billion picture training, it will be able to identify that which one. Let's use this different color. Let's imagine this is a fruit out here on the tree. Okay, and this fruit, whether this fruit is a raw mango, because raw mango will be green in color, and the ripened mango will be yellowish, or could be some kind of orangish, mangoish color, and which will be having the texture, right? Texture means a kind of a skin color, skin portion, the skin touch will be different, right? Raw mango will be having a hard skin. Okay, and this mango, which is ripened one, which will have a smooth skin, yellowish, very yellowish orange part, and a kind of a shape will be different. It will be kind of a soft in the skin, right? So that kind of a characteristic I train my model on 1 million pictures, and the moment it goes and try to check, or based on the color vision technique, it will be able to understand which one is raw and which one is ripened. It will be able to pluck out that fruit, and it will be able to store. In the basket, and the moment it will store in the basket, it will also do a automatic packaging, and it will be ready to be shipped to the markets. So that kind of application, when we talk about that kind of application, guys, that is called as computer vision. So there are multiple applications. This we have just seen two examples. There are multiple applications. Let it be a field of the communication. Let it be field of the health. Let it be a field of the agriculture. Let it be a field of a manufacturing. Let it be everyday's life. So this computer vision is playing a major role, guys. And it has been there. From the 90s. This is not generated something around the last 1 decade. It has been lying in our lives since the 90s. And that was the having different format. If you could remember our smart cameras, which can detect the face of the people. We can capture the camera, the photos, and we are able to do some photo mixing. Since that ages, when people used to use the cameras, color cameras, that ages from 90s, this computer vision exists, guys, but in one or other form. And now, when we had this software hardware, which was our camera, this hardware camera has been enabled with the AI. Now it is become a computer vision. So that is what the understanding, guys. And you can have a multiple sectors like this one. This example is a very nice example, where this drone is able to capture the image of a crop, and it is trying to analyze the crop. And this crop can be analyzed basis of this leaf, whether it is having any kind of a disease or not. And once it is able to detect there is a disease out there on the crop, it can spray the fertilizers accordingly. So entire 100 acres of farm will be fertilized within a couple of hours. So that kind of example, imagine that kind of a simplicity power is there in the computer vision. All right, guys. So having said that, enough to speak about when we talk about the computer vision. let's go and understand actually what is computer vision now. And very interesting thing, guys, very interesting thing we're going to talk about is how a machine able to identify the image, and how a human brain works, and how it is able to understand the entire image. Okay, so let me apologize you guys, because I'm going to take you to the biology class for next 10 minutes, because you guys will be shocked to know that we will go to 10 minutes. For next 10 minutes, I'm going to take you back to our basics class of biology, or you can say a human anatomy. So by using human anatomy, we're going to understand what is computer vision. Now ask me the question that, sorry, you seems to be very weird person, because here we are talking about AI, and why the hell you are going to this biology class today? So guys, try to understand the first statement which I did, right? First statement which I did about the deep learning, right? About the deep learning. If you could remember that deep learning uses artificial neural network, which are the copy of biological neurons. Okay, biological neurons. So if these are the copy of the biological neurons, we should be able to understand how the neural network system works, and then how the human brain perceive any particular image. Because in the end, what we have done, we are not God, we have not created these systems. These are created by gods. We are just making a copy. AI is all about making the copy of human intelligence. The way human speaks, the way human understand the context, the way human can reason. So we are copying that, become NLP. The way human understand the things and perform the computations or uses the stats become the machine learning, and the way AI try to analyze the images become the deep learning computer vision. So it is entirely a copy. It is not a man's creation. It is a creation which has been already exist in the human beings, in the living things. We are just making a copy of it. We are just making a live copy, and we are trying to take them into the statistical format. This is what the entire AI is all about. So that's why, guys, we need to understand how the human vision works. And once you understand how the human vision works, okay, once we understand how the human vision works, it will be very easy for us to understand how the computer vision works. So let's compare. Let's try to understand what is the similarity between computer vision and human vision. Okay, computer vision and human vision. So let's try to understand this one now. Okay, so let me adjust few things out here. All right. So guys, when we talk about computer vision, when I saw about the computer vision is a subfield of AI, machine learning, which enables the machine to see, understand, and interpret the visuals such as images, videos, or could be any kind of a visual, Okay, so this is what is all about the formal definition of computer vision. So let's try to understand. Let's go back to our now biology class. Let's try to understand now how the human vision works. So let's take example figure number 1 and try to focus out here then. So when I want to understand human vision, so I have to go to the brain of the human. This is the brain of the human, and this is the eye of the human. Now try to understand, guys. Try to focus, and for a few minutes, I want everyone to try to focus out here. So try to understand the basic functionality. This is not going to be a very difficult class of the biology. I know, because I hate biology. I'm being an engineer. So I left biology and choose the mathematics. So since I would not disappoint you guys, but still, since biology is not ready to leave me, because even I left biology is always behind me, and it is coming in some or other form. Just like today, it is appearing in my life as a artificial intelligence, computer vision. So let's understand this one. Okay, so let's focus on this figure 1, guys. Figure 1, and try to understand human vision. Let's imagine, guys. Let's imagine that I am passing one picture. This picture. This picture is all about the fruit basket that everyone is aware now. Let's try to understand, once I pass this picture, once I pass this image, what happens in the human brain? And how human brain try to conceive or try to conceive this kind of a vision system, how the human vision system works upon. So obviously the human vision system try to work on this three stages. Stage 1 could be capture the image. then process the image, and then analyze and then take the action. But this is not that simple. This is not that simple. Try to understand this one. Okay, so let's try to understand this one. This is not that important, and let's try to understand one concept called as a human vision. So the moment I pass this, try to understand this way. The moment I pass this is the entire human brain, and this is going through our eyes, right? This picture, let me draw this with some other notation, some other color. Let's imagine this picture is there, fruit basket picture, you passes. This goes through the eyes out here. This is the eye of a human brain. Human brain's eyes is there. This is go through the eyes, guys. This is go through the eyes, even this eyes, okay? This has some layers, right? This has some layers. This eye, human eye, goes through this human eye. This picture goes through human eye. This is something called as retina. Some kind of a, you can say some screen will be there. Some kind of a curtain will be there. And this will pass through this kind of a layers. This will pass through the layers, and it will try to enter. It will try to enter out here in the human brain, HB. You can say human brain, okay? So I have drawn an entire picture of the human grace. Try to understand here. Try to understand. Now let me rub the things and tell me a few things out here then. This entire human brain, guys, entire human brain is divided into 4 parts. Divided into 4 parts this way. So let me divide this human brain into the 4 parts. This is part number 1, this is part number 2, and this is part number 3. So part number 3, and this one, let me draw this with the different color now. The last one. So this last one, okay, this with the green color out here. This is the 4th part, 4th compartment of the human brain. So let's try to understand this way. So what is this 4th part and what is this responsible for? So this is brain compartment number 1. This is brain compartment number 2. This one is compartment number 3. And this one, the last one out here, the last part of the brain, at the back of the brain, right? There is a 4th part of the brain. 4th part of the brain that is called as cerebral cortex. Cerebral cortex. Cerebral cortex. Okay. So what is this cerebral cortex? Let's try to understand this way. What is this cerebral cortex, guys? This cerebral cortex, guys, this cerebral cortex is responsible for all the visual tasks, for the visual recognition task. Visual recognition task. Visual recognition task. Okay, let's try to understand this way. What is this visual recognition task? So this 4th part, guys, if you go back to Wikipedia, if you go back to any kind of a biology book, if you go to any kind of a medical research paper, you will find the same thing, that entire human brain is divided into the 4th part, and the 4th part called as cerebral cortex is responsible for the vision thing, guys. Vision recognition, visual recognitions, all vision related tasks are performed by this 4th part. 4th part of this brain, which is lies in the back of the brain. In the back of the brain. Now try to understand what happens here. Now try to understand how the entire functioning going out here. The moment, guys, the moment, okay. Okay, machine, nice. So you got to know new concept, right? So guys, cerebral cortex, what we'll do is, so when we pass this image, okay, it will go through the eye and it will go travel, okay, it will go through 1st layer, 2nd layer, 4th compartment. It will reach to the 4th compartment. This 4th compartment is cerebral cortex, and this cerebral cortex will work this way. Let me draw one diagram out here. So this is visual layer 1, there will be visual layer 2, and there will be visual layer 3, and beside that there is also visual layer 4 and visual layer 5. Okay, visual layer 5 now out here. Try to understand this way. So there are parallel. These layers are parallel out here, and then let's imagine in this way. So this first thing goes here to visual layer 1, then this processes, then this goes to visual layer 2, then goes to visual layer 3 and 4 and 5. 3, this is 3, 4 and 5, guys. Try to understand this way. Now let me draw and let me tell you again what is happening out here actually. The moment, guys, the moment this picture goes into the 4th layer, that is cerebral cortex has this kind of layers: visual layer 1, visual layer 2, visual layer 3, 4 and 5 simultaneously. Okay. So now try to understand how the entire picture is performed, or how the entire recognition tasks happen. Try to understand this way. How a human brain is able to understand that this is the picture and what this picture belongs to, and how they identify the picture. Now try to understand. So once I pass this information, information goes layer by layer, it is reaches to the cerebral cortex. In cerebral cortex, it will again go through the processing for layer by layer. This is layer number 1, visual layer number 1. This is layer number 2, layer number 3, and 4 and 5 simultaneously. Now what happens? The image comes to visual layer 1. Guys, try to understand. Human brain will never be able to identify the picture in one single shot. Okay, one single shot. That not happens. That what's not happens usually. We try to perform this visual recognition task in the layers. in the task subtask. Okay, try to understand what happens here. So the moment I pass this visual recognition, this layer 1 is responsible for the outer detection, outer boundary detection. You can say outer boundary, outer boundaries, outer boundary. What do you mean by outer boundary? Or you can say a contour, or you can say a contour. It's a very famous word called as contour. Contour, something like this one. Try to understand. If I try to take this webcam, so I am trying to draw outer shape of this, outer shape like this one. It is a shape of this one, half circle together. So this entire outer shape, when I try to talk about that outer shape, is called as contour. Okay. So the contour is nothing but a outer boundary. Now try to understand. When I pass my picture, so first job, the layer 1 job is to find out the outer contour, outer boundary. So in this case, let's try to understand this way. Let me use a different color now. So in this case, if I am passing this entire basket of fruit, so this is the outer shape. This is the outer shape out here. This is a half circle, and this is a bucket. This is a basket. Okay, this is what my outer shape is what looks like, right? This is what my outer shape look like. So this is recognized first. The first recognition is outer shape, that is responsible or done by the visual layer 1. Visual layer 1, V1. So I can call this as a V1. So V1 is, guys, try to find out this outer layer. And what is this outer layer? This try to understand the shape. It is trying to understand the shape, what kind of a size is there, what kind of a shapes is there. The outer one, but outer shape. Okay, outer shape. This is what is being done by the layer 1 now. Layer 1. And the same time, once it's able to understand the outer layer, then what happens? That's very interesting things happens. Once it is able to understand the contour, once it is able to understand the shapes and of some kind of a size, how big or how small is the shape or shapes is there, then it is tried to go in further details. Let's try to go for the further details. The information which is out here in the V1 can also be shared to V2, then also be shared to V3, and also be shared with the other layers accordingly at the time 1 only. But what happens, try to understand. Now comes the part for the second layer. Now second layer goes inside detail. It is trying to understand what consists of this shape. It goes deeper one level, and then it will be able to understand, okay, in this shape there are more circles. There is a banana. The banana will have this kind of half circle, and there is a something called as pineapple out here which looks this shape. Then there will be a custard apple, then there will be pomegranate, then will be something like that, and then it is able to understand the different shapes out here. So that is done by visual layer 2. So visual layer 2 try to understand all the shapes, all the sizes. It is able to understand the texture. Try to understand texture now. If this one is a pineapple, out like this one. This is a pineapple. Pineapple you have this kind of a rough skin. If we try to talk about the apple, apple will have a smooth skin. Color differences will be there. So this layer 2, guys, okay, let me rub these things and write it correctly. This layer 2 will now, what it will do is, layer 2 will try to find out the size, texture, the size, inside size, texture and the patterns. Texture and the pattern. This one is try to understand the outer size or contour. Okay, and then it is try to understand the text sizes and the pattern, text sizes and the texture sizes, and the maybe sometimes it will be able to identify some kind of a color scheme also. And this information is again passed with the some other layer like V4, V3, V4. In the GAST, guys, once it is able to understand the outer shape, then it is going inside this. It is try to understand this color, this kind of a shapes, small shapes, and this one. Then it is try to come up. In layer 3. In layer 3 and layer 4 and layer 5, now there will simultaneously where the final image will appear. Where the final image is going to appear. Final image going to appear in V4 and V5. Prior to that, in V3, guys, it is trying to understand the patterns. And it is trying to understand the features. And once it is understand V3, once it is understand the pattern and feature, then guys, then try to understand. Then the small shapes or small parts of the picture, like this one, small parts will get started recognizing, and this entire parts get recognizing. Then this combinedly entire picture, this combined visual is now appearing in the brain as a final, and then it is tried to classify, or try to identify try to identify the final picture based on our knowledge, because human beings don't come up with the entire knowledge. As a child, they try to understand. Like you guys remember when we are talking about the child, when the newborn child is there, which is just a 3-month-old, 4-month-old, doesn't understand the difference between the dog, cat, and anything. We try to teach it. We try to show it again and again, dog, cat, mom, pop, right, brother, Anna, right? Everyone we try to show them. It is really blank out there, right? First initial stage is blank. It only recognizes mother because it is the approximate proximity. It is trying to look at that picture again and again. There's something, this kind of a shape appears in front of me, and something have a connection to this one. This is how the child understand. Then the child grows. Then it is trying to understand the brothers and sister. Then guys, yes, you get the attendance. So you already, I think you will get to understand where you log into this portal, you'll get the attendance link feedback form. Okay. So my colleague Amar will also try to share these links. Don't worry. So guys, try to understand. This is how the entire picture and this is how the entire recognition happens. Okay. So what we used to think till now, the moment my eye sees the picture, I can understand. This is not what going to happen. This is how by layer it is trying to perceive the picture, guys. Layer by layer, it is trying to perceive the picture, and then the final image appears. Now, hope everyone understood. What is this entire picture is all about. How the human vision works upon. Now is the time to understand that how the computer vision works, right? So let me draw the same diagram. And tell you the same thing out here. So this is V1, this is V2, this is V3, and parallelly we have a V4, and parallelly we have a V5. And this is how the information flow goes on. This is something called as cerebral cortex. Okay. This is how the imagined parts work on, and these are the 4 parts which are available. 4th part is responsible for the vision task. All the vision task related tasks, right? Vision related task. So this is what we have understood, and now try to compare now. Try to understand what happens, how the entire process happens in the computer vision now. Let's try to pass the same picture. Let's take the same picture and try to pass this to the computer now. And what will happen, how the recognition will try to understand, guys. Since I told you day one only, like my first statement, that entire thing is copied. Now human vision is also copied. And try to understand the same way. There will be also layers. There will be some same layers like V1 layer, V2 layer, and V3 layers. And they in our convolution neural network. We will also have the layers in convolution neural network, which is famously called as CNN. So this CNN is responsible, and which is able to extract the things. It will be able to extract the information like layer wise. These layers, V1, V2 layer wise. Okay, this kind of a layers will happen, and within this layer, guys, it will try to take out the information, and it will later understand the things, guys. Just give me one moment, guys. Okay, guys, so let's try to understand this one. So when we talk about the convolution neural network, and when we talk about the computer vision technique, now it is a copy. So similarly, we will have a convolution neural networks. And this convolution neural network will also consist of the similar approach. Like we have seen here, V1 layer, V2 layer, V3 layer, V4 layer, V5 layer. And guys, similarly, this kind of approach will be also taken care, and it is form of some architecture which is called as convolution neural network, and then it will try to extract layer by layer. All something called as features. The features, we'll try to understand what is features. Okay, so it will try to understand by layer, guys, it will try to apply some filters. Okay, now try to understand there are 2 things. One is called as filter, and one is called as features. So we'll go in the detail. To try to understand these things. But prior to that, let's compare our human vision now with the computer vision and try to understand what is happening out here and how we apply the filter. And when we apply the filters, we get a features. And these features will make an image. And then the identification part will happen. Okay. So let me rub these things and now try to understand. So the moment the same picture, which is I passed through this computer vision, human vision technique, The same picture now I'm passing to the computer vision technique. Let's try to understand what happens now. So through the webcam, obviously through the cameras, we'll try to pass this picture. We'll try to pass this picture and we'll go inside our computer, our machine, right? And inside our machine, we have something called as convolution neural network, CNN layer, which is CNN layer. We'll try to understand the entire architecture of the CNN. Don't worry. As of now, try to understand this CNN is now works as a cerebral cortex. This is working as a cerebral cortex for the computer vision part, and this cerebral cortex, like we have a layer, it also have a layers, layer by layer, V3, and similarly here will be V4, and here will be V5. See, this CNN will also have these layers, this layering part, and every layer, like we understood, this part is able to look the outer boundary. This part is able to understand the shape, type, and text and share pattern. Then it will be able to identify the entire pattern. It will try to come up with the features. And once the feature comes up, it will be able to identify the entire image. That is what is going to also happen out here. So before we go into this discussion, let's try to understand when I pass a picture, what happens? When I pass a picture, guys. So when I pass a picture, guys, human brain or human eye can see a picture as it is, like this one. So when I pass this picture to human vision or human eye, okay, human eye will be able to see the things correctly, like this one. There is a car out here. There's a tree out here. Okay, there is one more tree. There are one more car is there. These are part. There is a roadway out here. There's a flower parts. This is the fountain out here. And now this is the sky. This is the sky, and this is a house. And this also has the stairs route out here. This is what the entire picture that human eye sees, right? But how it perceives it is different thing, which we already seen. But the picture which is passed is seen as it is by the human eyes. But that is not the case, guys. That is not the case in terms of the computer vision. So when you see a picture as a picture out here, so this is a picture. Let's imagine this is a building. This is some kind of a trampled stairs are there. Some road is there. This kind of a black and white picture, or let it be a color picture, like this kind of a picture. When you pass, guys, the computer vision will not see the picture as picture, guys. It will not see the image as image. This image is get converted into matrices, in kind of a matrices, guys. It will able to see this one. It will able to see these numbers out here. So these numbers are numbers. I will tell you what are these numbers. And these numbers, this picture, this entire picture now out here. Let me draw this denote with a different color. This entire picture, when you pass to the computer vision, guys, it is able to see this as a numbers now. This as a numbers, a matrix, number of a matrix, a kind of a matrix. Now there will be three channels. If I am passing a color image, it will create a three channels, guys. Three channels, okay? CHANNEL channels. So can anyone tell me, guys, if someone aware of these three channels already? So can you guys like quickly tell me what are the three channels which are available? Obviously. Awesome, guys. Awesome. So you guys already know RGB layers, right? RGB layers. So there are three channels. Which are already available. And that is why, because of this, awesome, guys. Thank you very much for your answer, guys. Krishna, thank you. Yeah, thank you, sir. Des, sir. And thank you, Abhaya, sir. Abhaya, thank you. So guys, try to understand. So when I pass this picture, okay, if it is a color picture, it will get converted into a matrix, three channels. These channels will be something called as RGB, red, green, blue. Okay, awesome, correct. So this is the red, green, blue channel which will be corrected. And once I am convert this color picture into three channels, this channel will contain the values which will be between 0 to 255. 0 to 255. Now let me ask you guys, why 0 to 255? Why not other? What could be the reason? What is the reason that these matrices which are getting converted as a picture as it is, those only contains the value between 0 to 255? So what could be the reason? Yeah, Krishna, correct. It's a range. Okay. So guys, try to understand why it is only 255, between 0 to 255. Let's imagine in this way. So guys, every picture, everything in the world, every shape starts with a dot. This dot is called as pixel. This dot is called as pixel, guys. This pixel. Okay. This pixel has a value, minimum value of 0, maximum value of 255. Maximum value of 0 and 255. Color, correct, guys. 0, black, 255. Correct answer, guys. So try to understand, guys. Try to understand here. So these pixels, the entire picture, guys. Yeah, correct, sir. Vijay Kumar sir, correct. Vijay Kumar sir, correct understanding that it's the intensity of pixel and the black for 0 and white for 255. Correct, guys. Correct. Awesome, awesome. Thank you very much for your answer. Now try to understand what happens here. So guys, pixels. So pixel is the least part, the minute part of the picture, minute part of the picture. Every picture, every scene, every picture, everything is made up of the dots. Everything is made up of the dots. Okay, try to understand this way, pixels. So now understand this pixel has a value of 0 to 255. So that is why imagine when you go and purchase kind of a TV or some kind of a display thing, kind of a thing, or that is why you always go for this kind of a quality, HD quality with this many 1024 pixels, right? Pixel, this many pixels, that kind of a things we try to check when we try to buy electronic item, which is trying to give us a display. Okay, so that is why we try to speak about the display, about the pixel intensity, pixel value 1024 or 4K. What is this 4K? 4K ultra HD, ULD or ultra HD 4K. What is this 4K? As this 4K is the resolution. Okay. So guys, Amar, can you please also share the attendance link once again with the colleagues? So people are asking for this. Okay. Yes, Deepamala ma'am. Yes, my colleague Amar will share the attendance link in the chat box. So guys, try to understand when we try to convert the picture, everything gets converted into the pixels, so the minute level detail of the picture, and this pixels has the value between 0 to 255 now. 0 to 255, and this once we apply this guys matrix. Okay, this is how the entire matrix will look like. These values will be associated to this picture. Values will be associated to this picture. If it's a black and white, it is a black and white, there will be only one matrix created, one matrix. And if it is a color, obviously there will be 3 matrices created, which contains this entire pixel values. And this, when we try to join these pixels, let's imagine this way. When I try to join these pixels, and when I try to join them, they will create the shapes. Okay, they will create the shapes. And this, when I try to combine these shapes, it will create an image. It will create an image, guys. Okay, so that is the link. That is the link. What is how the computer vision looks like. So computer vision only sees the numbers. It only sees the numbers, and the human, not like the human. So it is trying to see the numbers. These numbers are in the range of 0 to 255 RGB. If it is a black and white, it's only black and white image. One matrix is created, guys. Okay, so that is the first thing and foremost difference between the computer vision and human vision. And the like I told you, we also have a similar layers. So what will happen in the convolution neural network? There will be layers like V1, V2, V3, and V4 layers for cerebral cortex, like the cerebral cortex. And guys, then layer by layer, layer 1, visual layer 1, visual layer 1, visual layer 2, layer 3. We'll try to dilute. We'll try to dilute this picture. We'll try to dilute this picture. We'll try to convolute this picture. Convolute this picture. That's something called as convolute. There is a concept called as convolute. Convolute means we try to understand whenever a multiple, if you try to look at the actual meaning of the convolute means multiple artists or some people are coming together and playing some kind of a part, or they're trying to do a orchestration, a kind of a drama, kind of a presentation, kind of a show. Okay, so here also we try to convolute. First operation, what happens is convolute operation. So first convolute operation happens on the image when it is getting converted to this kind of a picture, this kind of a matrix, and this matrix will get convoluted. And once we convolute, guys, then we try to extract the features. How the feature extraction process will also work the same way. Like for the layer 1, we'll try to see the outer boundary, outer shape or outer size. Then in layer 2 also, we'll try to look at the shapes, small and inside shapes. Then try to look at the boundaries, patterns, and then final image will appear in this final layers. The final image will appear from the features. We'll try to extract something called as features. And from features, when we combine together this feature, the final identification of the image will happen. Okay, so similar way happens. So let's try to understand in detail now. Let's try to understand in the detail what is happening out here. And before we understand, guys, try to look at the one thing. That people say that computer vision is difficult. Why it is difficult? Try to understand in this way. So let me show you and let me tell you few concepts out here when we try to compare now computer vision. So now we have compared computer vision and we have compared a human vision. Okay, and on the basis of that, we are able to understand that there is something called as convolution neural network, CNN, which also works like the cerebral cortex, and layer by layer it is tried to extract the features. And once the feature extraction is done, so we are able to acknowledge the entire image, like we try to understand the things. Now try to understand why computer vision is a difficult portion. So first of all, we need to understand the one-to-one or one-to-many mappings. I'll explain you what is one-to-many mapping. Then it is a computationally intensive. Also, I'll try to make you understand this one. And then do not understand the recognition pattern very easily. Now try to compare these things and try to understand what do you mean by this one. So how the recognition part start? Try to understand this way. So what is recognition? What the recognition part starts? So let's imagine the colors. So here is a red color. here is the green color, here is the black and white color. The color is recognized. In recognition pattern, we have a color, then we have a something called as texture. If you try to look at this picture, this is a leopard. This is a leopard's picture. Okay, this is a leopard out here, and the leopard skin has a this kind of a dotted structure. There is a dots, black dots, and there is a beige color, golden color skin is there, right? Golden color skin is there. On that there is a dots are there, black dots. That is called as texture, right? Texture of the skin. And then we have something called as pattern. Because if you see the pattern, they both look like this one. Their shapes and their mouth look like this one. So if you try to take the family, right, let's see it this way. So I know I am very bad at drawing, so but try to understand this way. So it has a 4 legs. It has this kind of a mouth out here. It has a pointy ear. It will have a eyes, and it will have a tail also. The tail also, and it will have a pattern like this one. So this is something. This kind of a pattern is coming up, right? All these features are coming up. We are having a color. We are having a texture. Pattern is coming up. Obviously, there will be sizes, different sizes. And when we try to associate this thing, then the recognition will happen. Then the recognition will happen. Now try to understand what is the difficulty in the recognition. First of all, if I try to look at this picture is a satellite image. Okay. This picture is a satellite image. Even a human eye, when you see by human eye, you will not be able to understand what is inside the picture. You can say this kind of a building is there. There is one more building. But whether there is a building, whether there is a something called as a godam, some kind of a exchange is there, or whether it is a road, whether it is some kind of a military facility, or whether it is a school, or whether it is a living building, or whether it is a residential building. Don't know any clue. Whether it is a picture of the city, or whether it is a picture of the commercial complex, or whether it is a picture of the industrial complex, right? Whether it is a industries out here. So you don't know actually, but looking at the picture only, you cannot identify all the things, right? But there is something called as ambiguity out here. There's something called as ambiguity based on the only looking at the some structures, right? We don't have much information. Now try to understand these shapes are different, right? These shapes are different, and these different shapes, when we try to combine these different shapes, let's imagine if I try to combine this kind of a shapes together, and then when I join them, obviously it will become a flower. Right? So that is very important, that I see different shapes, different sizes and shapes, then I try to combine them together. These sizes or shapes or these patterns are called as features, guys. These are called as features. When I combine these features, I can it become an image. And then I can identify. Now, what is the difficulty? Try to understand out here. So this is actually a shadow. This is not a actual human. This is not the actual human. If you pass this kind of a picture where there is a shadow of the tree, there is a shadow of the child, there is a shadow of the man. Okay, so you will not be able to understand even by human eyes whether this is a shadow or this is a actual human being. That is the difficulty. That is the intricacy of the pictures. That is why they say the computer vision is difficult. Now to understand the real part. Now come back to the real part. Try to understand now. Like the same example of these leopards. Okay, this is a leopard which is shown in picture. Now guys, this leopard association, why this mapping is very important, how the mapping is difficult, try to understand this way. So guys, try to understand these leopards, all of them, they belong to wildcat family. Wildcat, right? They belong to the wildcats, wild big cats, right? Big cats. So there is whether you take an example of a tiger, you take an example of a lion, you take an example of leopard, you take an example of the cheetah, or you take an example of a panther, right? So now try to understand, even the human being is having difficulty because this everything looks like the same, but their shapes and sizes are slightly different. Their shapes and the sizes are different, but they all belong to the cat family. If this is the picture where I taken only half picture, so obviously you will think this is a cat, this kind of a cat, and all this belongs to a big wildcat family. So this tiger, this lion, this leopard, the cheetah and panther, they both have a tail. Everyone has a tail, everyone has a fur, and everyone has this kind of a shape which has a 4 legs, tail, and this has a fur. And now the only difference is the way they have a skin texture. Their skin texture is different somewhat, their sizes are different somewhat, and then actually the way they bark, the way they roar, their voices are different, right? But in computer vision, that is the difficulty, guys, because you have to associate the same picture. Same picture could be leopard, same picture could be cheetah, same picture could be panther. Very, very difficult, because human being will also try to fail to recognize this kind of a thing. That is why this says that this is a very difficult task, very difficult in computer vision. Now comes to the actual point. This says this is a computationally intensive. Let's try to understand this one. What I told you, when I try to look at a picture, even one single picture get converted to the three matrices. Try to understand this one now. How actually background works, how actually the identification works now this way. So when I try to convert this into the matrices, let's imagine single picture. This single picture get converted to the matrices, and there will be value between 0 to 255, like 0, 1, 2, 3, 4, 5, and any random numbers I'm taking 100, 150, or 200. Now try to understand, guys, when I try to do a computer vision task, we are trying to do a matrix multiplication, kind of a matrix multiplication. We're trying to do a matrix multiplication, matrix comparisons, right? Or we can simply say that whenever I try to take the picture, I try to apply this picture in the small parts, or small extraction parts. These small parts of bringing them into the smaller parts, breaking them into smaller parts, are called as filters. And I try to apply the filters out here, everyone in these numerical parts. On these numerical parts, I try to apply this kind of a filters, guys. Yeah, guys. Yes, Sairam sir. Yes, we'll share the attendance. Amar, can you please share the attendance link with everyone once again in the chat box? So
Yeah, sure.
yeah, okay. So guys, why it is difficult, from why it is called as competition intensive, try to understand. So whatever picture we are seeing, everything is getting converted into the three matrices. So for one picture, three matrices. Now try to understand these three matrices, guys. These three matrices is further getting divided. These three matrices are further getting divided into the multiple matrices, multiple small matrices, which is called as filter. And this filter is actually responsible to draw or dig out the small parts in the picture, like this one. There is a child, there is a human, there is a tree, and there is a grass out here, there is a color. So for everything, let's imagine there will be, if you take a simple picture and if you try to divide it into 100 parts, so there will be 100 filters. These 100 filters will be now compared with these three filters, and they will do a matrix multiplication. Now try to understand. This is for one picture. One picture we have created 100, means 3 into 100, that is 300. For one picture 300, imagine, guys, one picture 300, and for one picture if I am creating 300 filters, 300 matrices, then imagine when I am trying to train my computer vision model, at least I pass 10,000 picture each. 10,000 picture each means for one class. Imagine this way. If I'm trying to find out the big wild cat animals, so imagine for cheetah, for leopard, for tiger, for lion, each, okay, let it be number of ways. I try to pass at least minimum 10,000 images. For 10,000 images into 3 into 100, guys, try to understand. 10,000 into 100 into 3. So now trying to understand how big the number will be and how big the calculation should be. That kind of a calculation are performed. Then after end of this calculation, we are able to extract the feature. And these features combinedly perform the prediction. Now tell me, guys. So that is a difficult task. Let me rub these things. That is why the CPU will fail to perform this kind of a task. That is why they have something called as GPU. Everyone aware, guys, what is GPU? What is graphical processing unit? Everyone is very aware. And then they have something called as TPU now. Tensor processing unit, okay, TPU, which is very, very famous and which is used by the packages or the framework called as TensorFlow and the Keras, right, in the background, which is developed by the Google. So we'll try to understand these frameworks going forward. We'll try to understand what is this framework is all about and how it is converted to the TPU, guys. Try to understand. TPU is a tensor processing unit. And tensor, guys, tensor is a n-dimensional array, ND array. It is a multi-dimensional array which holds the multiple matrices. Together. Let it be any kind of a n dimension. N-dimensional matrices are there. It is try to hold these matrices and in that form of the tensor, and then it perform the calculation. Parallelly for on these billions of images. So that is why we require a special hardware called as TPU and GPU, guys. Okay. So everyone understood what is TPU, what is GPU, graphical processing unit, and why we require this kind of resources, and that is why it is called as computationally intensive. So that is the reason why the computer vision task is not that simple, and it's a take time. It's take time to understand the things, guys. All right. So hope now everyone got a very good background about how the things works upon and why it is difficult. What is computer vision? What is human vision? And let's try to understand in next 10 minutes what are the popular tasks for the computer vision. What is the popular task? And then we'll try to conclude our session out here once we understand the computer vision task. And then in next session, we'll try to go into the detail of the convolution neural network. We'll try to understand when we pass a picture, how it is get divided into the layers, what is the layer responsible, what kind of operations perform, and how the picture passed and how the prediction performed. And we'll try to set up our own architecture for the convolution neural network. So try to understand, guys, very important task, very important thing, that what are the major tasks when I talk about the computer vision. Now, first task when talk about the computer vision, guys, image classification. So what do you mean by image classification? Let's take a very right example out here, and we'll be able to understand. Guys, I'm going to give you a real-time examples, and with that real-time example, I'm going to explain you what is the task performed by the computer vision. All right. Okay. Yes, I will explain, sir. Harshil Kumar, I will explain this 100, 300 into 1000. I will explain because we're going to understand in detail. So in my next lecture, we're going to perform this calculations. You will understand this, what is happening out here. Okay, I'll focus on that. So let us complete, and in next session in detail, like we'll understand everything. Chat box not visible. Rosa ma'am, please, I think you should have an option in the Zoom meeting which will show you the entire like icon, kind of a message icon. So there you will have a chat option, chat box. That is the chat box. So I think you can refer to that one. So guys, try to understand our entire image classification task. What is image classification? Okay, so try to understand what you mean by. Let's take a simple example. I'll give you a real-time example on a project which I worked upon when I'm working for this kind of a medical application company. This is data analytics company, which is based in the Singapore company. So what they are an end-to-end medical application, and they wanted to understand what is the food intake. Okay, what is the food intake any person is staying, looking at his food picture. Looking at his food picture, they wanted to understand the food intake, and they want to classify whether he's eating healthy food, whether it is a junk food, or whether he's eating a medium okay food. Okay, so that kind of a bifurcation you wanted to understand. Let's try to understand the first example. First task which is done by the computer vision is called as image classification, and how image classification can be out to our use to the real-time use case. Try to understand. This is the picture of the plate, guys. This person is eating a pizza. And this one more picture is provided where it is having a eggs. It's a egg with a yellow part, and there's a meat out here. So this kind of a picture once I pass, guys. So this picture can be classified. They will be able to detect whether this picture is belonging to a non-veg section. And if it is a non-veg or vegetarian, then out of that, it will be able to understand even whether it is a pizza, whether there is an egg, or whether this is a flesh. There is a flesh. Okay, that kind of a things. When I pass the image, it is able to classify. That is called as multi-class classification, guys. Okay. So all right. Thank you, ma'am. Rosa ma'am. So let's try to understand this one. That kind of a classification. If I pass a picture, and once I pass a picture, it will be able to tell me that I am eating pizza, or whether I am eating a flesh, mutton, chicken, whatever thing, or whether I am eating an egg, guys. And what will happen? If I am able to identify my plate, this entire plate picture, and I'm able to identify these things, it will obviously I know the calories. The pizza will have around 1000 calories. Flesh will also have around 1200 calories, and this egg will have something around like 50 to 100 calories per egg, 150 calories. So this way I can check the portion and can classify. I can classify the food intake into the categories: healthy food, non-healthy food, or okay food, medium food. And this is how, guys, entire end-to-end automation I can do. Only every day you don't have to do anything. You have an app. You click a picture of your plate, click a picture of your entire food plate, and it will be able to identify, and it will be able to calculate the food intake in kilocalories. Okay, that kind of a task is called as computer vision task. This is image classification. You can classify the image. There are several things how we can do a classification. Now try to understand the second popular task which a computer vision can perform. This is called as something called as facial key points recognition. Facial facial key point, facial landmarking. Facial landmarking, guys, try to understand. If you see this picture, entire picture out here, when I try to pass the entire picture, this is the entire human picture, this is the face. And on the face, guys, you can see there are at least 56 to 60 facial key points has been identified. Facial key points has been identified. Now, what is the use? So you can see there are facial key points related to the nose, this upper, lower nose, nostrils. Then there's a lower chin, upper chin, and then there's the eyebrow, left eye, right eye, then forehead, then these cheeks, then the chin, and I can measure the distance. I can measure distance. Even I can measure the distance between the eyes. Between the eyes, I can check the nose. I can check the distance between nose and the mouth. Whether this mouth is open, upper lips, I can check the upper lips and lower lips distance. And these guys, what could be the things? What could be the things which you guys can analyze? So you can analyze the emotions, looking at these facial key points and the coordinates which are called as X and Y coordinates, and you do a distance calculation. You will be able to understand whether this eye is open, or closed, whether this mouth is open or closed, how is his nose position, how is his cheek position, and I can do an entire emotion analysis. How is the person feeling? Emotion analysis, or whether this person is winking his eye, okay, whether this person is laughing out here. This entire calculation, guys, I can do using the facial key points, right? The moment I pass a picture, I calculate these facial key points, I do a distance calculation, I could get the coordinates, and then I can decide the emotion, whether person is smiling, whether person is laughing, whether he's winking his eye, whether he's talking, whether he's angry or something like that, right? So that is a very, very popular task performed at the computer vision. That the task is called as, guys, now task is called as facial recognition. Similarly, guys, we have something called as, let me rub and try to finish this in 2 minutes, guys. I know we guys are already past the mark. So let's understand this third task now, human pose estimation. You can see this person. So entire skeleton structure, you see this guy, if you see this guy is in a gym. So entire his skeleton structure I can see here. I can get the coordinates like this one. So entire structures, and basis of this, guys, I can do a action recognition, whether that person is playing, whether this person is walking, whether person is running, whether he's doing gymming, or that kind of a human pose estimation. Then we use something called as object detection. You can see this live traffic camera. You can see this circles, rectangles. So it is able to identify the vehicles. It is able to identify entire this nameplate. It is able to identify this MACD board also. You can see there is a MACD board, displays the human, the pathways, the cars, the traffic signal sign, everything in the building, their board, the people out here. That is called as object detection. That is also one of the famous tasks. Then something called as this segmentation. You can see the car is segmented, means drawn with a different color. It is trying to find out the contour. It is trying to draw color with a different color. Similarly, the grass, the sky with the blue color, grass with the green color, trees with the green color, the path with the black color. There is a similar object are colored with the similar thing, and this is called as object segmentation. This will help to track the object, find the object. And similarly, last task which we can see out here is the medical fingerprints. You can see face detection, fingerprint detection, medical imaging, and some other tasks which is very, very popular. Something called as gait analysis. Gait analysis, guys, by not only looking at face, but looking at the key points, like entire your structure, this one, entire your skeleton structure, your hand movement, and the position of the key coordinates. I am able to identify whether this is a Vikas person or not, or this is Vikas or something else who is there out here, like whether it's a Anand, whether this is a Chandana ma'am, whether this is a Amar. Okay, so this kind of a things I am able to identify is called as gait analysis. Medical positioning, medical identification through the fingerprints, through the faces, through the gait analysis, by looking at your skeleton position, looking at your entire picture, your height, your width, your skeleton position, your length between the legs, everything, guys. Okay, that is very, very famous use case called as gait. Without using the face also, you can identify the person. All right, guys. So I think biometrics also comes under it. Correct, Mohsin? Correct. Okay, guys. So this is all about the computer vision and their task. I think this was a very, very good interaction session where we started to understand what is computer vision. Okay, what is the difference between human vision and the computer vision? How the computer sees, how the human sees, how the entire human vision works. We saw the biology class, and then we were able to understand why it is difficult and what are the major tasks which are performed by the entire computer vision classes, entire computer vision topics. All right, guys. So I think we'll try to stop out here today and try to continue our discussion tomorrow. We'll go back into the detail and understand this convolution neural network, and we'll try to understand the further things then. Right? So guys, thank you very much. Amar, can you please once again share the link for the feedback and for attendance? So that will be easy for us, everyone, to track this way. So there is a popular demand once again from the colleagues and from the people. So thank you, Amar. So hope you guys enjoyed today's session, guys. So just please give me comments and let me know. And then over to you, Amar, then. Thank you very much.
Yeah, sure. Thank you so much for such a wonderful session. So my dear participant, I shared the attendance and feedback link in the chat box over Zoom and YouTube as well. So please go ahead and mark your attendance and don't forget to share your valuable feedback first as well. And if you are facing any difficulty, if you have any query or question for XLR team, EDL team, please let me know in the chat box. I will take it up. Okay.
All right, guys. Thank you very much then. So that's it for today. So we'll meet tomorrow then. Thank you, guys. Thank you for your comments.
Participant, any query or question? Done. Okay. No any question. Can we attend a recorded session instead of live session while you're forwarding certificates? No, it's not like that. To get the certificate, live attendance is mandatory and you have to mark your attendance and it should be more than 60%. Okay. Okay, thank you. YouTube participant, any query? If not, then we'll wind up for the day and we'll meet you on tomorrow at the same time. Thank you so much for attending the session and we'll meet you on tomorrow. Chandana, can you please stop the session?
Yes, Sam. I'll wind up the session.
Yeah, sure. Thank